Dear students, please pause the video and try this question. Please test your skills before we reveal the answer. So we have to find in how many above industries green hydrogen can decarbonize in future. So even if a student doesn't know anything about green hydrogen, if the basic awareness that hydrogen is a type of energy source or a fuel, rest is given in the question itself. This hydrogen is green. That is, it is related to renewable energy. As a result, it can decarbonize wherever this green hydrogen is used. And question is asking in how many industries this green hydrogen, that is a renewable energy related hydrogen, expected to play to decarbonize. Expected to play means in future. See, this is the most crucial phrase in this question which will help solve. So in future, just think rationally. In future, any new technology can come which can use green hydrogen in any industries. So as a result, all will become correct. It's a very direct hint. If we read this properly. Okay. Only thing you have to take care of is to check whether any option given has any direct contraindication with the given fuel or the main keyword. If there is no direct contradiction, interpret this as very broad thing and go with all of the above. Okay, such a simple question UPSC has asked. You can also share your thought process in the comment section about how you approach this question. It might help someone else who is preparing. Now we have to know why we are producing this hydrogen. We know about different types of hydrogen: green, black, yellow, blue, gray. So why we are producing this hydrogen? See, hydrogen is the one of the lightest element. Hydrogen is very abundant in universe, but in Earth, hydrogen is found mostly in combination with the other elements, especially as water and as hydrocarbons in Earth crust, like coal. Why this happens? Why hydrogen is not found in Earth as a standalone molecule? Because it is very light. So it can easily escape out of Earth's atmosphere. So that is the reason we have to produce different types of hydrogen to use it as a fuel. Okay. From this basic knowledge, we can study green hydrogen. So this is hydrogen gas produced by electrolyzing water. So I told you, hydrogen is mostly found in association with the oxygen as water. So from water, we are producing by electrolyzing the water using renewable energy source like solar energy or wind energy. As a result, the greenhouse gases emitted during this production is near to zero. Okay, so this is how we split water into hydrogen and oxygen. So this is the process. Using wind energy or solar energy, we electrolyze the water and split it into hydrogen and oxygen, and we store the hydrogen by compressing it or liquefying it. We will store the hydrogen. You can also store by combining it with some metals as metal carbides, sorry, metal hydrides. So in future, any industry can be decarbonized by green hydrogen, including aviation, because in future technologies will develop. So steel, refinery, fertilizer, shipping, heavy transport, power generation, residential, anywhere green hydrogen can be used. Now coming to India's National Green Hydrogen Mission, remember this value: 5 million metric tons of green hydrogen production annually by 2030 is our goal, because sometimes UPSC has the habit of asking this target. Now, coming to the challenges of green hydrogen, we need, of course, massive renewable energy capacity, and high cost of the process of electrolysis, then we need, of course, water, but we are facing water stress. And infrastructure is still under development, like how to transport, how to store, pipelines or hydrogen transport, all are still under development. Now, coming to the very important aspect, the challenges of storing hydrogen. See, most important thing is low energy density of hydrogen. If you take a certain volume of this gas, the energy density in that volume is very less. So we need to compress it because this is a very light gas. To get this certain required amount of energy density, we need to compress it or liquefy it. Okay. So that requires energy. Now, while compressing, we need heavy reinforced tank to store it. And the risk is leak and explosion. We all know that hydrogen is very highly inflammable gas. And also it liquefies only at minus 253 degrees Celsius. Very, very low temperature. Okay. So that is also very difficult. Then all these storage methods, compression, liquefaction, metal hydride, or combining with any other chemicals, all are expensive and not yet competitive with the fossil fuel storage. And this was asked in PYQ. Okay, that's why it's very important. Now coming to different types of hydrogen: black, gray, brown, blue, green, yellow, turquoise, pink. So based on the source and the method of production, the type of hydrogen varies. So first, you will see black hydrogen. So the source is coal. Okay, bituminous coal is used, and this coal is partially oxidized. It is gasified. Okay, we partially oxidize this coal, and we will get oxides of carbon and hydrogen gas. Okay, so we will take this hydrogen gas. When lignite coal is used, it is called brown hydrogen. Okay, when bituminous coal is used, it is called black hydrogen. Both are polluting because when this oxides of carbon is released into air, it will look black and brown. Now coming to gray hydrogen, here natural gas, mostly methane, is used, and process is steam reforming or steam methane reforming. So we are reforming methane using steam in water. Here also you get oxides of carbon and hydrogen. Since this is less polluting, the air will look less darker than black and brown. That is why it is called the gray hydrogen. Blue is also the same process as gray hydrogen. Only difference is the oxides of carbon released into the air are captured and stored. So the air will look again blue skies. So that's how you can remember blue hydrogen. Okay. Then green hydrogen that we already seen by electrolysis using renewable energy source. A subtype is yellow hydrogen. We are specifically using solar energy. We are doing electrolysis. It is yellow hydrogen. Pink hydrogen also use same process, electrolysis of water, but here nuclear energy is used. Okay, that is why it is called a pink hydrogen. And lastly, turquoise hydrogen. Here the process used is pyrolysis. Source is natural gas. So methane is thermally decomposed. So we heat it to split this methane, decompose this methane into solid carbon and hydrogen. Okay, and this solid carbon will be used in industries like fire manufacture. Okay, so pyrolysis, of course, another PYQ, thermal decomposition in the absence of oxygen. Okay, that is pyrolysis. So that's it. These are the types of hydrogen. Thanks for watching. If this helped you, please give it a like and subscribe for more UPSC insights.